Hi, I'm Dror Sapir. This is Lab8 Lasers.
Hey, my name is Ozer. The first part of the lab, we aligned the cavities to create a laser, and we got different CEM modes. The second part of the lab, we used the Febri-Perot interferometer to create and to find the mode separation. In the third part of the lab, we changed the distance of the detector to profile our beam. Here, as you can see, we aligned the green laser to go into each aperture, meaning it's aligned until it hits the white paper. So we created a laser. We made it laze. It's TEM00, and now he's changing it to TEM01, which introduced losses.
And higher order right here.
There we go.
This is a demonstration of how we can get higher modes from the laser that we created. And we're going back to TEM00. The laser tube is slanted so we can be at Brewster's angle, and we calculated right here using this formula that at 1.5 N we get 56.31 degrees. That's the angle, and the polarization is going to be high loss for S, which means it's p-polarized. This is our data. The three frequency peaks that we have are right here. 1, 2, and 3. These are the peaks, and they occur at this right here, F equals C over 2L. In order to use the C over 2NL equation, the N value is going to be 1, and the L value is the length of this cavity, which we measured using a ruler in centimeters. This is our given FSR value, which is 10 gigahertz. Then we got the FSR reading on the oscilloscope, which is 231.5 kilohertz. We got a conversion factor using these two values, which is right here. And then we also measured the inside to outside peak, which gave us this value, the outer to outer peak, which gave us this value. And we modified them using the conversion factor, which is these two values right here. And then we got delta nu value using this, measuring the length of the cavity and using this equation right here. And we compared it to the one that's given on the tool. Here what we did is we modified the distance to the detector, and using these modifications of the distance, we measured the diameter of the beam at each spot, and we got our data this way.
So this is the data that we got for different distances. We got different beam diameter. Then we modified the beam diameter to get the beam radius and the beam radius squared. And then we graphed it, the beam radius squared, in respect to the distance to get a quadratic function.